Thank you so much, Rachel. So hi, everyone. My name is Isabel, and I'll be moderating the discussion today. I'll be looking at the chat box to see questions that everyone has both during and after the presentation, perhaps jumping in during the presentation if there's a question that's directly relevant to the slide at hand. And I'd like to start by introducing the speakers for today. So let's start with Jadish. So Jadish Patel is the founder and CEO of Flow Labs. Jadish has over a decade of experience in advancing cutting-edge transportation technologies globally as an investor with Fidelity Investments, and is the co-founder of Allocating Technologies, a European leader in transportation data applications. Jadish is an expert and thought leader in artificial intelligence for traffic management applications. Our next speaker is Carl. Carl Novelli is the Assistant Vice President in Public Sector Sales at Wejo. Carl has a background in information technology and telematics and has been providing technology-based solutions for over 20 years. Carl is working with DOTs, municipalities, cities, and universities to help them harness the power of connected vehicle data. He is also in the process of relocating to the Raleigh area. And as I said, I'm here to moderate and to provide a bit of a grant writer's perspective. My name is Isabel Barani. I joined Flow Labs about 1.5 years ago, and before that point, I've worked in communications in the nonprofit, healthcare, education, and community development sectors.
Thank you, Isabel, for that kind of introduction. So just going into a little bit about Flow Labs, for those of you who haven't heard of us already, we are a software company based out of Oakland, California. We help transportation agencies solve some of their biggest problems, leveraging data-driven solutions. At the core of how we operate and our solutions, we focus on solutions which are infrastructure agnostic, designed to leverage existing systems and interoperate with all of the key systems that agencies have already deployed, which also makes them affordable within the budgets of existing budgets of an agency. And we focus on future-proof technologies, leveraging connected vehicle technologies, as well as the ability to interoperate with any form of geospatial data so that they can add value today and in the future. And what we care most about is really performance and impact, helping agencies leverage artificial intelligence to be able to measure and optimize roadway performance.
Thank you for that. So a quick introduction into Wejo. We are the largest provider of connected vehicle data globally. So what that means is right now in the United States, we have over 13 million vehicles that are providing us information every 1 to 3 seconds. So how we do this is we work directly with vehicle manufacturers to help them enable those vehicles to provide data out the door to entities like departments of transport, MPOs, cities, universities, engineering providers, and platform providers as well. So a key note here is the data is fully consented data, is anonymized to a point, and it is standardized as well. And essentially a couple of other key takeaways here are there are no aftermarket devices on the vehicles providing us information. It is simply the vehicle itself providing this insight. And we work with partners like Microsoft, Iteris, Moonshadow, Texas A&M Transportation Institute, and of course, Flow Labs.
Awesome. Thanks a lot for that intro to Wejo. Between Wejo and Flow Labs, we spend a lot of time speaking with transportation agencies across the country as well as nationally. And one of the questions that you always ask people is, what is the biggest challenge that you're facing today? And often you might expect to hear something like safety, but really the most common answer we get to that question is that for transportation agencies, they have lots of projects to do and very little funding to do them with. So today's presentation is really going to be discussing how to use connected vehicle data, artificial intelligence, machine learning, and novel technologies to measure the ROI of any project. But really, we're going to be focusing on how that can enable agencies to better prioritize their projects so that they can get the biggest bang for their buck. Number two, be able to leverage that information to increase funding availability. And number three, to be able to reduce project costs so that they can do more with less. One of the things that's very clear from our conversation with a lot of agencies is that over many, many years, a lot of different technologies have been invested in. We've gone through waves of improving communication infrastructure, as well as sort of the IoT era as well. And what that's left us with is with a huge amount of information from detection devices, from traffic management systems, from transit data, from crash histories, from work zone data feeds. But often, even though there's a huge amount of data, it can be very, very difficult to use. For one, data is often siloed within different operational departments and even within different servers. Often as well, given the scale of that data, it's quite difficult to manage and process. A lot of the talent required to be able to manage data infrastructure is very difficult to find. It's a very competitive marketplace for that type of talent, making it very, very difficult and often costly to be able to process that data. But often worse still is even where that data exists, it can also be incredibly inaccurate. In our own studies, looking through, for example, detection data, which is a primary source for a lot of major automated applications, we've found that the data accuracy levels can be very, very variable. We found that in a major detection quality study that less than 28% of detectors are providing reliable data. But what that also means is a huge amount of difficulty for operations as well as planning. Having inaccurate data creates false alarms, rate surfacing the wrong issues, but also they result in missed issues as well. And what that means is that when you can't trust the data sources that are available that you've invested in, it means that operators often have to spend a huge amount of time going out into the field to actually get the data that they can trust. Huge amounts of data collection is still highly manual and still requires huge amounts of personnel to go out into the field, visually observing or conducting drive testing. This data acquisition method is labor intensive, but it's also costly in the face of rising labor costs. But also, you can only send people out for a very short period of time. And often that means that that data can get outdated very, very quickly. Now, one of the things that we focused on at Flow Labs to help agencies solve this problem is by working with partners like Wejo, who can provide a completely new layer of insight to be able to complement existing data sources and generate a huge amount of additional information.
I think the key here is when we say connected vehicle data, what do we mean? What is connected vehicle data? We hear terms of floating car data, different kind of terminology is bounded around, and essentially it does mean slightly different things. So when we say connected vehicle data, we mean actual vehicles. So right now, the Wejo data set consists of passenger vehicles from 4 vehicle manufacturers, making up over 13 million vehicles in the United States. So the real exciting piece here, sort of following on from the train of thought here, is you're not having to send people out into the field. This is simply the vehicle itself providing information as to where it's been, where it's going, how it's being driven, direct from the vehicle head unit. So no aftermarket devices, up to the manufacturer cloud, across to ourselves, where we standardize it, we anonymize it, and we provide it out the door. And the key here that I mentioned earlier is the data is fully consented data. And this allows us to support different marketplaces like mapping and navigation, government municipalities, engineering and construction, and of course, signal timing as an example here. So on to the next slide, you'll see the granularity of the data. So this again is key when understanding different data assets. What does granularity mean? So when we mean that, we are each data point, so imagine that breadcrumb trail from ignition on to ignition off every 1 to 3 seconds in the Wejo data set for our movement data is essentially down to 6 decimal places. So what that really means is it's about a 3-meter circle. So really granular, you can start to understand lane level usage, parking bay usage, and really to getting that bird's eye view on your road infrastructure of what's going on. The volume of the data. So as we mentioned, over 13 million vehicles providing us this information gives a really good understanding of what is going on. So we have Purdue University up in Indiana, who's published many papers using this data, one of which does dig into penetration rates. And on average across the US, we're anywhere between 3 to 7% penetration. As I mentioned, the 3-second capture rate in our movement data. So essentially that breadcrumb trail to understand where vehicles are going and how they're being driven. And bear in mind, this is consented data and it is anonymized to a point. We also have historical data. So thinking around the previous slides that you've seen, the challenge of getting a workforce out on the roadside and having to capture counts, what's going on there. Imagine a situation we've had recently with the hurricanes in Florida. We have data right back to October 2019 and everything in between. So it doesn't matter what the weather situation is on the roadway, these vehicles are consistently providing this information. So you're not having to worry about putting people out in the field with a high-vis jacket on and concerned, are they safe? Are they not safe? Is it raining? Is it snowing? What is the impact? These vehicles are constantly providing this information without any interaction from the users whatsoever.
So one of the real advantages that we've found by leveraging data sets like Wejo's connected vehicle data is in combination with all of the existing data sets, it has a huge amount of power to unlock a huge amount of value out of existing data sets. Now, what do we mean by that? One of the things that connected vehicle allows us to do is to be able to generate more extensive coverage. For example, if you are deploying a hardware-based technology, it really generates data only from the specific place that it's installed. With connected vehicle data, because you're tracking vehicles across large areas, you're essentially filling in all of the gaps, creating much more extensive and scalable coverage. The second major benefit is that by providing an additional data source, an additional perspective, can also use that to be able to clean out bad data and increase data accuracy. But the other great thing is that what you'll find is that every single data set has a huge number of strengths, but it also has weaknesses. When it comes to connected vehicle data from Wejo, we found that the real benefits have been around understanding vehicle mobility data, as well as some safety metrics, which are often very difficult to capture with other data sets. So by using this information, we're able to combine it all, generate a much more complete and holistic view, which we'll kind of come on to later and show exactly what that means. When it comes to generating greater accuracy, in our research and studies, we found that just using, for example, probe data alone and just using existing road sensors, they can often be quite inaccurate and lead to not reach the levels of accuracy that are required for the majority of major applications. By combining that data together, cleaning out bad data sets, leveraging artificial intelligence and machine learning algorithms, we can now generate highly automated turning movement counts for any given roadway, high volume areas, low volume areas, as well as areas without any existing detection at all. So more scalable, more accurate coverage. The second big piece is now by combining these different data sets, we're also able to generate substantially more dimensions of data. For example, safety is obviously a key measure that's important, and often agencies are highly reliant on just leveraging crash statistics. For the vast majority of projects, being able to go down that method, you're really waiting 6 to 12 to 18 months to generate enough crash history data to understand what the statistical significance is of any key measure or countermeasure that you've deployed. But by using this type of data, we can focus more on leading indicators as opposed to lagging indicators, be able to measure safety risks, speeding, red light running, hard braking behaviors, be able to quantify it instantly and continuously, so be able to get metrics on a daily basis, as well as being able to very quickly and instantly identify the biggest crash hotspots.
I think where this gets really exciting is I always use the analogy that we are a layer to the story. The more layers that you can build up of that story, the greater your understanding of exactly what is going on those roadways. So this slide kind of pulls out some of the use cases our movement data has, and our movement data can be provided, as we mentioned, historically, or in that near real time with a 36-second delay in what is going on. So imagine traffic management, understanding what's going on out there, not just reliant upon cameras and roadside detection, but also to the point earlier of filling in the gaps, what's happening in between. But again, if you could imagine you're in that operations center and actually you're starting to see a slowdown of vehicles in the connected vehicle data against the trend, because it may be Monday morning and you know on a certain intersection that there is always traffic buildup. But now what you're seeing in the connected vehicle data is actually that buildup is more than usual. So what that's saying to your operators, get my teeth in, is actually we need to put a camera there. There's something going on that location. So again, you know, the theme here is this is a layer to the story to see what's going on. An example that I wanted to bring up here as well is around sort of project selection and following on from the previous slide around utilizing crash data. So as we all know, crash data is a key prerequisite for a lot of safety projects. You've identified a number of crashes, and most traffic engineers for a city will know their crash hotspots within a city. We have a layer of data called event data, and two of the key metrics there are hard braking and hard acceleration events. And the interesting part is a paper that Purdue University have done where they've correlated for 147 hard brake events at one location, there will then be an accident. So where this is, and keeping that sort of theme in mind around layers to the story, you've got 10 locations in your city or your MPO or a district that you're looking after. They have a very similar number of crashes, but now using this hard brake, hard acceleration data, it's another way of scoring where do we need to focus our attention. If now you add in another layer that says actually weather is a factor, and again, we can see windscreen wiper state change and speed, actually, it could be that in a certain location, it's only an issue when it rains. Maybe in that location, then it's drainage. But going back to a sort of standard one where you're seeing crashes, number of hard brakes at an intersection, you've then decided using data to make that informed decision, that's where we're going to focus our attention. And you do something about it. There is an action on that section of road. Whether that action is as simple as improving the signage, improving or reducing the speed limit, as an example. You then do that change. And to follow on the point that Jatish made, which is rather than waiting for 18 months or even 5 years, has that change been effective? Have we succeeded? Because this data is constantly being collated and can be constantly provided to you in different formats, you can then see we made the change on the Friday. We've now waited a week, and actually, well, are folks still hard braking, or are they hard accelerating at that location? Have we impacted change? Are we seeing a reduction? Or has our change actually impacted the surrounding roads? So the good thing is, because you're getting data for that bird's eye view for all of those roads, because it's just where the vehicles are, not reliant on that external sources, is really giving you that understanding to do that after action reports. Has this made an impact on that? Do we need to go back and do something more? Or is the change that we've done sufficient enough? So it really helps with project selection, but also understanding the impact of those projects.
I'm just going to jump in here for a moment because we were just sent a question to the panelists. I think this directly ties into what we've been discussing right now. So someone has asked 3 interrelated questions. The first question is, what is the accuracy of your data? How do you, and I assume this is for both Jatish and Carl. So what is the accuracy of this data? How do you remove duplicate data from DOT collected counts from roadside deployments? So how are you, I assume this is around how are you cross-referencing data in order to build accuracy? And cost information, is this subscription based?
So happy to jump in there with a few elements, and it's nice the people that are on this webinar, we can give sort of different views on this. Accuracy of the data is down to 6 decimal places. So within our movement data, our source data, it is essentially the granularity of about a 3-meter circle. When we look at duplicate counts, I think this is really interesting. So we don't do any extrapolation whatsoever. The data that we get from the vehicles is simply the data we get from the vehicles. But to your question specifically, if then a DOT has a tube count out by the side of the road, actually that's another layer to the story. Because as I mentioned earlier on, we don't see every vehicle utilizing that road. We see on average anywhere between 3 and 7%. So what you would then do is look at that tube count on that section of road that will be capturing 100%, normally with direction of travel as well, and essentially tie the two together to say, what is the penetration rate? How does that marry up? Hopefully that gives some sort of information there. With regards to the data set itself, our source data isn't subscription based. It can be. So that's maybe the wrong answer and a bit contradictory, but as a default, if you said we wanted to buy a month's worth of data, that could be a one-off purchase. If you wanted a reoccurring drop of data, it could be that you want that for a year, and that's something that we could put in place. I think an element here as well is the tools to utilize and understand data. And this is where I'll lean on yourself with regards to flow labs and things along those lines. So having an application or a tool to understand, visualize the data, how does that sort of pricing work or modeling work?
To speak to some of the things that Carl mentioned there about data accuracy, it's a difficult question to ask in a simple way because there are many different dimensions of the data that have different measures. So for example, are you talking about count accuracy? Are you talking about speed accuracy, locational accuracy? All of those are of different levels, but in terms of the real world studies that we've done, actually even validating Wejo's data, the accuracy levels we've found have been incredibly high and incredibly demonstrating clean data. When it comes to integrating multiple data sets, that's something that we're especially good at. And to the point of duplicating data, it's a little bit of a different question when you're cross-utilizing connected vehicle data with, for example, detection or RSU data. Those different data sets, we have a number of different algorithms that allow us to identify matching vehicles, as well as incorporating different latency levels between, for example, the vehicle data as well as the detector, and accounting for that. But there's a lot of different ways and different tools and techniques, some using machine learning, artificial intelligence, some just using very kind of hardcore brute force software engineering algorithms to do that. When it comes to pricing as well, again, we focus on a subscription-based model for our products and analytics. The reason why we do that is because the vast majority of our costs really come down to data processing, which is really dependent on, I guess, the input data feeds and kind of the continuous feed of that. And really kind of the aim is to make sure that it is an efficient and low cost, affordable product that allows engineering teams to be able to use it within their existing budgets.
Awesome. Well, there are a couple more questions surrounding accuracy, but I think let's hold some of those until the end just to make sure we have time to get to the whole presentation. But thank you all for asking questions. I see them and we definitely will get to them.
Safety was just one major dimension, but especially with the new administration and environmental impact has become an increasing focus. It's attracting a huge amount of additional federal funding, as well as a huge amount of focus from a state regulatory perspective as well. And so by combining all of these different data sets at Flow Labs, we've been able to leverage that information alongside the EPA moves model to generate highly accurate environmental impact metrics at scale. Now, the benefit of this is to be able to generate information on particulates and vehicle emissions by different particulate types, as well as measuring fuel consumption, as well being able to do this at any scale from an entire region all the way down to even the smallest road. What this means as well is that by being able to continuously measure environmental impact and be able to do it in an affordable and low labor intensity way, it increases the potential number of projects that you can fund with environmental focused funding, for example, CMAQ funding, which requires measurement and monitoring of emissions as part of any project. The other major benefit is to be able to measure impact in non-attainment areas and understand whether a region is meeting attainment targets. On the previous point, just to give you an example of a project that we conducted around signal timing, using artificial intelligence to optimize signal timing for major corridors, because the technology was able to measure down to that kind of lower level, being able to understand what's happening at every intersection, every movement, we were able to measure the vehicle emissions reductions for that project, as well as quantify the total potential for reduction, including unnecessary emissions. So for example, helping understand exactly how much emissions can be reduced. For example, here on the charts, we were able to also generate vehicle emission metrics on a per vehicle basis as well to help understand what is the actual emissions, what is the, I guess, the optimal emissions for vehicles that are going through and going at free flow speed. So again, by being able to have continuous measures, you're able to access or make funding accessible for even the smaller projects by reducing the reporting requirements and reporting costs and the measurement costs. So when it comes to multidimensional data, that's really the benefits when you can unlock all of the data, take it out of its silos, integrate it together, combine it with connected vehicle data, and generate a much more complete and accurate picture. So in terms of the measures that are available, you can generate huge amounts of information around not just operations, but mobility, safety, environmental impact. And as you add newer and newer infrastructure, you can get higher accuracy levels for all of these different data sets and dramatically improve operations. So going back to our original point and the original purpose was, what can you do once you've been able to have this data and being able to measure the ROI of your projects? You know, number one is enabling you to better prioritize your projects. If you do have limited funding, where is the biggest impact for that every dollar spent? Where is that going to be? And so at Flow Labs, we provide tools like Cerberus, which is our proactive monitoring tool, to be able to capture this data on a continuous basis. So now you can have a look at all of your road networks, corridors, signals, any segment of roadway, and be able to quantify performance at every given time, being able to prioritize issues based on severity and identify candidate projects instantly. You know, really the goal is to be able to have a ready list of every single problem area at any given time, so that when new funds come out, when you are going after new funding, you already know which projects are already going to be in place for that. As well as that, being able to provide the information to be able to prioritize them based on severity, but as well doing it based on actionability as well. We have time for a short demo here, but this is just an example in a real use case of this is kind of the level at which of granularity that Cerberus provides, being able to leverage connected vehicle data, other data sets to be able to understand, get a full list, allowing agencies to prioritize based on any key criteria that you care about, as well as being able to prioritize for example, pedestrian safety applications as well. The second major use case for this data is be able to increase the funding available to your organizations and your teams. So one of the main benefits is that by being able to instantly measure project performance, you can generate a very clear and quick picture on exactly what the ROI of any of your historical projects were, and be able to use this to be able to quantify the future benefits of any upcoming projects. By being able to do that, you can also reduce reporting workloads for funded projects. One of the things that we found with a lot of agencies that discourages them from even trying to capture federal grant funding is the amount of reporting requirements once that project is completed. A third area is that by having all of this data available, agencies can now create more compelling grant narratives and create winning applications to increase and maximize the chances of getting funding. And when we talk about reducing reporting workloads, being able to measure the outcome of a project is an incredibly difficult and laborious process. It involves a huge amount of field-based data collection that could take months, with huge amounts of labor time, and can actually cost a substantial amount of the entire project costs. And just going to give you a sense of how easy you can make it when you have good tools. Here's an example. This is Litmus in action. You can take any given project in any given area. Take, for example, a signal timing project. All it is as simple as setting the before and after periods, being able to set what days of the week you care about, what time of day period, and be able to quickly and easily generate a full report on the exact outcome of that project. So this is a real outcome report. Have a look at the impact on traffic patterns, have a look at the reductions in travel time and delay, have a look at the reductions in control delay, reductions in environmental impact, massive improvements in safety, as well as boiling this down to a simple ROI number of around $120,000 per on an annualized benefit for a project which cost about 21 cents of compute power. So really here, being able to boil this down into a very clear economic argument for any of your projects and being able to do it in mere seconds.
Thanks, Jadish. So now I'm going to talk a little bit more about the grant writing piece of it, leveraging my own experience as a grant writer. So what we're seeing is under the Biden administration, grants are prioritizing performance measurement. And we're seeing that being reflected in the notice of funding opportunities, which I'm going to refer to as NFOs. I'm sure this is a term many of you are familiar with. Now, in my experience as a grant writer, the number one mistake that people make when they write grants is they're not following the grant instructions, or in this case, the NFO. I know that sounds, kind of obvious, but it's actually in some ways deceptively difficult to do, to be able to hit as many of the directives in an NFO as possible. That's, in my opinion, that's the difference between a grant being successfully funded and not successfully funded. How many of the strategic goals are you able to hit? How many of the priorities or aims of the funding program are you able to hit? The more that you can speak to specifically, the better your chances are of winning that funding. And so what we're seeing right now is that even in the NFOs that are open currently, prioritizing projects and being able to measure projects is a big part of these NFOs. So in SMART, that comes out in the quote, in the NFO, there's a quote, measurement and validation of the cost savings and performance improvement. And ATTAIN, which is the other big one that's currently open right now, it's the demonstration, quantification, and evaluation of the impact of these advanced technologies. These are taken directly from these NFOs. So as you can see, there's slightly different ways that federal agencies or the writers of these NFOs are, talking about performance measurement, but they really are talking about performance measurement. Here's what we're also seeing under the Biden administration, and specifically the Biden infrastructure law. We're seeing that the Biden administration is prioritizing projects around climate and the environment. We're seeing that it's prioritizing projects around safety. We're seeing that they're prioritizing projects around equity. And in addition to this, they're prioritizing projects that are kind of sort of at the intersection of some of these themes, as well as projects around innovation. And I even want to draw your attention to this because I think this is really interesting. The FW, the Federal Highway Administration, actually even has a grant. This was created through the Biden infrastructure law. This is the prioritization process pilot program. And it's, quote, to fund the development and implementation of publicly accessible, transparent prioritization processes. So it's actually an entire grant around prioritization, which is really interesting. And this does show, this gives us more information about what these grant evaluators are interested in. So, Yeah.
Just to kind of add on to one of the points that Isabel's making here is really that by being able to generate more holistic performance measures, you can take any given project and be able to craft a compelling narrative on the same project for whether it's an environmental narrative or a safety narrative or an equity narrative, and really gives you the flexibility to be able to go after whatever new funding source comes out of and whatever big funding pool exists. We know that transportation projects are incredibly complex, both in their execution, but also in their impact and benefits. Any transportation project has a vast number of impacts, whether it is on equity or safety or environmental or mobility, and being able to communicate that in the way that you want to is incredibly important, and something that better data and more complete data can support.
Yes, thank you so much for that point. And just to quickly talk about how this, can work on equity. What you might want to do when you're building your narrative is look at projects in marginalized communities, and then you can talk about, well, here are the outcomes that we've seen before. Here's the ROI before. And so because we know this is what we want to do to be able to increase outcomes and ROI in this marginalized community. I think the term that USDOT use is historically disadvantaged community. And of course, they have a tool that can allow you to, did your PowerPoint? What's that?
Got it covered.
Okay. So as I was saying, you can use this tool, which is publicly accessible, to find out whether this community, any community within your system, qualifies as a historically disadvantaged community. Now let's talk a little bit beyond Biden about some older programs. So something that's interesting is if you're able to do comprehensive environmental performance measurement, you can also go after other types of funding, such as EPA funding. So the EPA has several grants that fund the reduction of P2 pollutants, and agencies, of course, need to be able to measure how much these pollutants have been reduced by. And the last bit I want to talk about is to talk just even a little bit more concretely about how can comprehensive performance measurement support grant narratives. So what happens when you're able to accurately and completely measure mobility, safety, environment, and operations, which in turn is going to help you being able to measure equity as well. Well, if you have a comprehensive performance measurement solution, you can establish a clear starting point for your project. So this is where we are right now. Here are our key performance indicators and ROIs for past projects. And then if you have a research-backed prediction on how your project is going to improve outcomes, then you can take those same numbers and say, here's where we're going. Something that's really important for grants, and I kind of alluded to before, is specificity. Clear numbers over just saying, words such as improve, help, are going to be much stronger and much more compelling, because the grant reader is going to be able to better picture what you're talking about. It's going to be able to be more specific. And if you don't have comprehensive performance measurement, then you can include that as part of your application of what you want funding for. And you can say, here's our very clear plan for how we're going to measure and validate our projects. So with all that being said, Jatish and Carl, do you have anything to add?
I think one point that I just wanted to mention, and it's a project that I've been involved in recently, is when we look at charging infrastructure, and especially around equity, making sure that locations are not left behind. So traditionally, charging infrastructure has been put into locations of high value. So one of the things that you can actually see is if you put it in charging infrastructure in an area that traditionally wouldn't have seen EVs, you can actually measure that utilizing connected vehicle data. So what I mean by that is within our movement data set, you can actually ascertain the powertrain of the vehicle. Is it an EV? Is it a hybrid? Is it a combustion engine? So you can do that before and after study. So before you put the charging infrastructure in an area, were there any EVs going to that area? Does that kind of ascertain, does that mean that actually because there are no EVs, it's a disadvantaged area? Potentially. If you then put charging infrastructure in that traditional disadvantaged area, and now you see an uptake in EVs, you've got a really good before and after study to help demonstrate how you've used that grant money to make change and make improvement. So I just wanted to bring that one to light.
Excellent. And the third and final, third core benefit really is an additional benefit of having better data to be able to reduce project costs. Now, we already talked about being able to reduce reporting workloads and reduce project costs that way. But also one of the added benefits of having your data consolidated, combined, integrated, it means that it's now available to use for other automated tools, for example, operational decision support tools like one of our tools, Optimus. And what that means is that now you can also reduce the overall costs of delivery, leveraging new technologies as well. The added benefit of that as well is that by being able to reduce your overall cost per location, you can now take the same amount of funding for the same project and be able to increase and broaden the scope so you can have an impact across an even larger area. So just in general, really the core benefits of having good, clean, accurate data, really that it allows an agency to be able to scale their impact pretty dramatically. And what really that means is that you can start being able to have generate cleaner, clearer, and safer roads for all of your road users. This is an example of a project that we did recently, where our technologies were able to generate reductions in emissions, reductions in travel time, reductions in crash risk, as well as offering agencies an incredible benefit to cost ratio. So just to wrap up in terms of the overall presentation, so we have some time for Q&A, the key lessons from our presentation really that agencies can leverage connected vehicle data, add that as a key tool in the toolkit that can help not just provide new insights, but also unlock insights from existing data sets, enabling agencies to access information on mobility, safety, environmental impact, and equity across your entire system on a continuous and instant basis, allowing you to identify and prioritize projects based on need and actionability, be able to create compelling grant narratives and access more funding, but also be able to combine that data with innovative tooling to drive down project costs and make a larger impact faster. So we'll leave it, we've left some time for questions and answers, but if anyone does want to reach out to either Carl or myself and Isabel separately, please use the emails available, or if you do have a phone available, please just use the QR codes and that'll make it even simpler for you. Isabel, are there any questions that that have been highlighted by the audience?
Yeah, let's just go in order. So the first question is, I think this is a connected vehicle question. Does cloud/rain/weather, tall buildings, etc., impact accuracy?
So a great question. As a default, I would say no. And I'll probably lean on Jatish and your sort of research around utilizing our data. But that used to be an impactor on cellular data, where the footprint of the ping, as it were, was much larger. So you used to suffer with, we used to call it canyoning. Whereas because the granularity of the data is much more granular, excuse my use of that word so many times, essentially that does get over that problem.
We haven't seen any issues, but at the same time, we haven't done in-depth research in those specific areas yet. But in terms of, we haven't seen anything that suggests that the accuracy levels are significantly or meaningfully lower than in other areas.
Great. So the next question is also an accuracy question. As I mentioned, there are some accuracy questions. Given the 3-meter accuracy, does data successfully differentiate between two vehicles beside each other on the roadway, given lanes are generally a bit wider than 3 meters?
Absolutely. I think it's important, and the key behind this question is how the data is captured. We're not relying on roadside capture or Bluetooth capture or anything along those lines. It is simply the vehicle itself providing this information every 1 to 3 seconds. So using that example, if you have a freeway, and let's say on that freeway there are 10 vehicles that we are capturing data from. So bear in mind, we see between sort of 3 and 7% of all journeys on the US roads. each of those vehicles, so from ignition on to ignition off, that breadcrumb trail will have a static journey ID. So if you had 4 vehicles on that section of road, you would be able to differentiate from those 4 different journeys. So you would be able to ascertain almost down to lane level usage. And the reason I say almost down to lane level usage is the footprint is a 3-meter circle, but it can drift slightly, but you would be able to ascertain if a vehicle is remaining in one lane. Hopefully that answers that.
Great. So the next question is, how do your solutions differ or align with, differ from or align with telematics solutions? How do your solutions differ from or align with V2X deployments in the field?
So both great questions. I'll sort of lean on my background as actually selling and providing telematics solutions. I think if you've ever worked for a company and they sell you your vehicle is being tracked, it has a telematics device in that vehicle, your driving generally will be in a slightly different method. And bear in mind, telematics providers are generally providing those devices to fleets who are actively monitoring and scoring the driver on their performance and how they're driving. Are they speeding? Are they hitting the brake too hard and things along those lines? Whereas connected vehicle data and the data that we provide is anonymized and it is standardized. So the difference being the drivers of those vehicles, they have consented the use of the data, but essentially the data is not being used to monitor that individual driver in any way. It's simply looking at the journey. So it's a much more real version of what is going on your roadways. So hopefully that gives a little bit around that piece. With regards to how do we differ or align with V2X deployments in the field, again, vehicle to X is slightly different. What we're describing is data direct from the vehicle, utilizing no physical infrastructure around whatsoever, up to a manufacturer cloud, across to ourselves, and then out the door. So one of the benefits you've got with the connected vehicle data that we provide is, especially imagine that rural example, so there is no infrastructure. We're not relying on that V2X situation. It is simply the vehicles as they drive down the road providing information. Whereas V2X is more around if you are driving a vehicle and you're coming up to a traffic light, it may potentially show you in the vehicle the light sequence. So hopefully that gives a little bit of clarity around that.
And just to add on to that, in terms of comparing connected vehicle data, like Wejo connected vehicle data with CV2X, I guess it's not an either or situation. There are different benefits and different use cases. What we've found is that using methods like Wejo connected vehicle data, it's more scalable, less requirements for infrastructure. A lot of agencies as well, we found, don't have the budget to be able to deploy huge amounts of hardware devices at scale. And really what they want to be able to do is be able to identify the select locations where that hardware investment can also have the biggest impact and be able to leverage, for example, Wejo connected vehicle data everywhere else to make sure that they get full coverage. So it's not really an either or. The cost differential is pretty substantial. The types of data you generate are also different as well. They have their strengths and their weaknesses. So it's really, I guess, what we probably more focus on is helping agencies see a holistic picture and be able to use them as complements, not as competitors, really.
So the next question is, what sort of local detector data sources do you use to augment the connected vehicle data?
So again, I think this goes back to the question of how is the data captured? And the key here is the data is actually the vehicle itself providing this information. So we're not relying on that physical infrastructure to capture the data. I think there was a question above as well around vehicle type, for example, truck data. And this is a great question. So one of the things that we see is, bear in mind, this is anonymized to a point. So we wouldn't be able to tell you, for example, that a journey was made by Isabella's F-150 and it was white. What you would be able to see, though, is from ignition on to ignition off that breadcrumb trail, you would, in our passenger vehicle data set, be able to see it was a pickup truck. it was an SUV. You'd be able to tell an age of manufacturer and a powertrain information. But it's that level of granularity that we do provide. So unfortunately, we don't have all the answers, but we're definitely a layer to that story.
From our perspective, when it comes to detection augmentation, we're pretty agnostic to detector types and locations. Predominantly, the majority of detectors on roadways are really deployed in and around intersections, whether they are signalized intersections or whether they are, for example, a ramp meter can count as an intersection as well, also freeway detection. Pretty agnostic to detection types, but just really wherever they exist the most. When it comes to augmentation of the data, it's difficult to really say that we're using detector data to augment connected vehicle data, or we're using connected vehicle data to augment detector data. Really you're marrying the two and to generate kind of a more holistic picture, and it's kind of difficult to kind of blur those lines. But really a lot of what we're doing is being able to use multiple different data sets in the same location to be able to generate different perspectives and identify any anomalies that exist between them. So for example, whether there is an issue with connected vehicle data or whether there is an issue with detection, a lot of our algorithms allow us to identify which side of the equation the issue is with. Is it a bad detector? Is it bad connected vehicle data? And there's a whole variety of different algorithmic techniques that we can use that allow us to understand what is accurate and what is not. I know that's a somewhat vague answer, but if we went into detail, I'm happy to go into detail offline. If we did it on this call, it would take another hour of your time, which I wouldn't want.
So our so we actually have a couple questions about this. It seems that this technology is only available in newer vehicles. Could this cause gaps in data for certain communities?
So one of the exciting things is, and we do get this question a lot, is it the most expensive vehicles out there? Is it the brand new vehicles out there? And the answer is no. To a point, potentially, the oldest vehicles providing us information are a manufacturer date of 2015 and newer. So like I said, we don't see all of the vehicles on the roadway, but we do see a statistical relevant amount. And I think that's one of the key takeaways here. And I know there's a question asking around that sort of 3 to 7% and whether we see that increasing. Absolutely. We know that that volume is increasing. We are constantly working to onboard new OEMs as well that will increase our footprint from that standpoint. But essentially the key here is there enough data to provide accurate information? With connected vehicle data, we've seen a number of papers published. We've seen DOTs that are starting to utilize this data. And the answer is absolutely there is. And I think one of the exciting things that we've kind of mentioned as we've been going through this as well is by adding in some of these other data sources, that's when you really get the accurate picture. So I think if you were to utilize just one data set over another, that does work, of course it does, but the real power of all this is trying to utilize as many as possible to get a really clearer picture.
And to speak to that as well, one of the things at Flow Labs that we really pride ourselves on is being able to kind of squeeze as much juice and value out of the data that exists. I think one of the difficult things as well we've seen from a lot of people is really letting perfection be the enemy of greatness, which really means that trying to get 100% accuracy in every dimension whilst missing the fact that you can actually get a lot of very useful data out of what we have. So yes, 3 to 7% sounds low, but what we've been able to do is actually leverage that information, combine that with other data to be able to generate very, very high levels of accuracy that can support a very, very large number of high value applications. Now, really, as you get higher and higher accuracy, that increases the number of applications you can go to. But even our studies being able to leverage Wejo, we've been working with Wejo since early 2020. So we've kind of seen as well firsthand the way that their penetration levels have actually increased, even in the short time that we've worked with them. But secondly, one of the things that we also saw was a lot of the data actually, interestingly enough, that we put in the presentation were actually from a time when the penetration rates in the area that we were studying were significantly lower than that 3 to 7% range. So we were in a low coverage area a while back where it was 2.1% penetration. We were able to generate those high levels of accuracy. What we're seeing is as the penetration rate of that data increases naturally, even with the same algorithms, the data accuracy dramatically increases over time. And we see that only going one way.
I think it's important to remember where we've come from. I had a great conversation last year with a traffic engineer. He was based up in Colorado, who made the point when asked, how often do you get data counts? And he said, well, we only get them on a sunny day when it's warm. And I asked the question, but you're in Colorado, it snows. Oh yeah, we don't do counts during that time of year. So it's that where we've come from, where we are today and where we're going. I think it's important to kind of tie those bits together.
So one question that was from a while ago was, it was mentioned that CV data is around 3 to 7% along an arterial. How quickly do you believe this will scale to have a larger sampling, including reaching 50 or 75%?
Yeah, and I think to some of the points that we've kind of made here is it will increase. The key here is the element around the statistical relevance. And as that increases, we know that even if it's below 3%, it's enough information to really understand what's going on. For example, an example of that is if you were to utilize hard braking data and tie that with crash data. If you looked at a city and over 24 hours in the life of that city, you are seeing at one intersection, there is a lot of hard braking going on. That tells you that there's something happening that probably you need to focus your attention. And whether that's just changing the direction of the camera so you can see, well, why are folks slamming the brakes on? There's something happening. It's enough to make you sort of stand up and pay attention to that location.
Great. Well, I think we're almost at time. One other one I see that could probably apply to both companies on the call is, have you considered adding micromobility data?
I guess we can take that. Yes. I think the core goal for us is to be able to integrate any type of data to generate insight and combine that with other data sets to see exactly what can be done. Now, micromobility data is pretty new to the market, but it is actually provides some pretty interesting insights, helping understand what are the key micromobility routes, and as well cross utilizing that with vehicle data to understand the areas and routes where vehicle behaviors can cause risks for micromobility riders, and be able to understand those aspects as well. So yes, it's currently on our roadmap. We have started investigating, integrating that. But again, trying to figure out as well, balancing with certain cities on data privacy issues as well is one hurdle that also needs to be overcome there.